Alright guys, welcome to the course. So before we get started, the first thing we're going to need to do is download our IDE, and we're going to be using Visual Studio. This is where we're going to edit and run our code. So come to your favorite search engine. I'm here at Google, and you're just going to type in Visual Studio. And the first thing that come up should be visualstudio.microsoft.com. And you can actually just type that in the browser if you want to, but let's go ahead and click it. And if you scroll down a bit, you have three options. What you're looking for is Visual Studio, first one here on the left. And if you have Mac, you're going to download Visual Studio for Mac. So if you come down to the download and you click Community, that's the free edition. So you'll see Community 2019. And if you're looking, depending on when you're looking at this video, you might see a later version. Just get whatever the latest version is. So let's go ahead and click that. And your download should pop up in the left-hand corner shortly. There it goes. Let's go ahead and open. Click Continue. Alright, from this screen we're going to pick the components that we want to be installed. The first one is the .NET desktop. We're going to also use the data storage and processing. And from here we're just going to click Install. And we're going to let this installation run, and it should take about an hour. Alright guys, so now that the installation is done, it's been about an hour. We're going to go ahead and click Launch. So here we just got to sign into Visual Studios, and if you don't have a Microsoft or Visual Studio account, just go ahead and create one, or you can just come down to not now, maybe later. Alright, this brings us to the Visual Studio home screen. Now you guys might have gotten some other options that you're not seeing here. There might have been some options for like picking a mode. It might have said like dark mode, light mode, and that's kind of just the text. So it's not a big deal. Pick whatever you want there, and it can always be changed later. And I think that's a good stopping place in this video. In the next video, we'll go ahead and get started with your first app. See you there. All right, welcome back. So in this lesson, I'm going to get you guys a little more familiar with the .NET platform, and we're going to write our first app. So let's go ahead and get started. So here we are at the home screen of Visual Studios 2019. So what we're going to do is go down to the Create Project at the bottom right-hand corner. And what we're looking for is Console App. So we're going to type in the search bar, Console. App. And we're looking for the one that says console app .NET framework C#. So go ahead and click that. Click next. We're going to give our project a name. We're going to call it Hello World. For the location, this is where all the files associated with the application are going to be stored. We're going to keep it at the default location. The solution name, we'll keep it the same. And for the framework, we just want the latest framework that's available, which is already pre-selected. So we're going to leave that the same. So we're going to go down to the bottom screen here, bottom right-hand corner. We're going to go ahead and hit Create. All right, here we are. So the first thing you'll notice is there's already some pre-written code or text on the console. It's about 16 lines. Let's start at the very top. At the very top, you'll see There's a using keyword followed by more text. What these are naming spaces. Now, depending on your version of Visual Studios, you might not see all of the naming spaces, or you might have more, you might have less. Um, Again, it just depends on your version. As you can see, they're grayed out. That's because we're currently not using them. And they can be thought of as pre-written code, pre-written applications, or pre-written code that makes our coding easier. We can call on these naming spaces to utilize their functions. So don't worry too much about that. We're going to get really deep into the course, and we'll talk about naming spaces a lot throughout the course. So as you come down, you can see we have our own namespace, which is Hello World. And everything is basically contained into these two brackets. Below that, we have a class called Program. And class is going to be a concept that we're going to cover more as we move along. Inside this class, we have what's called a method, and it's your main method. Now, most programs are going to have some variation of a main method. And what a main method simply is as soon as a program is called, this is where the compiler looks first for its instructions. So that's where we're going to be writing our initial instructions, or our first program inside the main class. Oh, sorry, the main method inside the program class. So let's go ahead and get started. So first thing we're going to do, we're going to write console dot write line. Now, console is a class that's associated with the system namespace. As you can see, it's no longer grayed out because we're now using that namespace. Write line is a method. So the console calls up the console, which I'll show you guys what that is in a little bit. And write lines is a method to basically read whatever goes into these brackets. And inside these brackets, we're going to write hello world. And after every line of code in C#, you need to put a colon. And what we're going to do next, well, first we're going to fix this hello world. Now we can run our application. So we're going to come up here up top where it says start, and we're going to click start, see what we got. And as you can see, the console pops up and it disappears. That's because we need to tell the application to wait for a response from the user before you close out the application, because the only instructions here are to just, hey, show this on the console and then close the application. So the way we can do that, we can say console dot read line. Colon. So let's run that again. You see, hello world, and it stays there, and when you hit the enter key, it goes away. Now you guys might have noticed when you typed in write line, or as you were typing it in, there was two options that came up. One that said write and the other one that said write line. Now the only difference between those two is that write line has an escape character at the end that creates a space between the first line and the second line. So let me give you guys an example. So let's just go down and write another line of text here for console, say console.write line, and we're going to say line 2, and we're going to put a colon, and we're going to run this. Pretty simple, right? Hello world. And then the second line we wrote is line 2. So what we're going to do, we're going to comment this out to show you the example of just show you the difference between right and right line. So the way you do that is the / twice, and that comments out everything that you put on that line. And you can see it's in green now, so the application won't recognize anything that's written there. So let's come down, type console.write instead of write line, and we're going to call this line 1 colon, and then we're going to console dot write line 2 colon. And I'm going to show you guys what the difference is. As you can see, they're both on the same line now, and that escape character wasn't added to basically create that space. And we'll get more into escape characters as the course goes along, but just wanted to give you guys a quick preview because I know that's a common question as you're first learning. You're seeing these options that are similar and you're curious on what the difference is. I think that's a good place to stop. We learned a little bit about the console, what we could do, the naming spaces, and we wrote our first application. So I'll see you guys in the next lesson. Thank you. All right, welcome back. So in this video, we're going to get familiar with the user interface. So let's go ahead and get started. Let's start over here on the right in your Solution Explorer. And your Solution Explorer is going to contain all the files that are associated with your project. And as we go through the course, you guys will get familiar with some of these files and what they are. Right below that is your Properties window. So your Property windows is going to give you more information or context about a selected item. So as you can see, as we select items here, we're getting more information about those items. And certain items you're able to modify and change their properties. The largest window is your code editor. And this is where you're going to write your code. So whenever we write methods, classes, or we're building out our program, everything's going to go here. In our hello world, we use this section to write out our code to print something to the console, where we said console. So we wrote our hello world and it printed to the console. So right below that is your output window. And this is going to contain any kind of debug or error messages that are associated with your code above. So for an example, if I got rid of the last little bit here, it tells me that a colon is expected on line 13. And you see the red mark here. It basically tells you where the error message is as well. So let's put that back. Let's look at some of the menus. Up top here is the file menu. It's going to contain a lot of the things you need to open new projects, create projects, and save them. Next, the edit menu is going to contain things that will allow you to refactor and modify your code. The next important element here is the start button. The start button is going to allow you to run your code. So anytime we write some code, we want to test it out, see how it runs, we're going to hit the start button. We can also hit F5 as a shortcut. As you can see, after we hit the start menu, our output had some log information regarding the run. And the console didn't stay up because we don't have the console.read method here to keep the console up. And the next important window to know before we kind of get started into the course is the tools menu. And this is going to allow you to change your settings and add functionality. So if you guys remember when we first installed Visual Studios, you probably had an option to select a theme. So I'm going to show you guys how to basically change that theme now. So let's go down to option, and under the general, you see you can change your color themes here. So if I said dark, click OK. And as you also saw, there were other options there as well. So you can go back, play with that, see what works for you, see what kind of experience you like. And I think that's a good stopping place for this video, guys. Just wanting to give you a quick tutorial of the UI, just so you understand the important elements as you're learning to code. Alright guys, welcome back. In this video, we're going to cover variables. And variables are just containers to store data values. So let's take a look at our second line here. This shows the syntax for declaring a variable. First thing you're going to do is say what type it is. So it can be a float, double, int, or a string. Then you're going to give your variable a name, followed by a value. So below you see an example. We have an int, and we called it my number, and it equals 7. So whenever I call my number and I print that out, I'm going to get 7. And this is some of the examples of the primitive data types. Far from all, but just wanted to give you guys some examples. So we have the int that stores whole numbers. So for an example, 123 to negative 123, the double stores decimal floating points. The char, which stores a single character. The string, which is text. You guys remember this, we used it for our hello world. And bool, which stores values that are in two states, either true or false. And in the next video, we're going to cover kind of the exact ranges for these primitive data types. But for now, just wanted to give you guys a general idea of what they are. So after we declare our data type, the next thing to do is to name your variable. So just wanted to go over a few rules as far as naming your variables. The name can contain a letter, digits, and an underscore character. The first character of the name must be a letter. So we can't use numbers or special characters or anything like that. So the case matters. Uppercase my variable is different than lowercase my variable. Lastly, C# keywords can't be used in variable names. After this video, there'll be a resource page that contains all the reserved keywords in C#, and they are strictly off limits for declaring as variable names. So let's look at some examples. The first one here, we have the word percent, capital P. The rest of the letters are lowercase. This is perfectly legal. The same thing here, capital Y. There's an underscore. There's some numbers, all lowercase letters, perfectly legal. Same thing with yearly underscore cost. And the next two variables are also illegal. The first one containing an illegal character, and the last starting with a digit. So as mentioned before, C# is a case-sensitive language. So percent all lowercase, percent all uppercase, and percent with a capital P all lowercase are all considered different variables. It's common for C# programmers to only use lowercase letters when declaring variables, but there are different styles, which includes camel notation and Pascal notation. Now for some tips. You should always use variable names that are descriptive. So you want to shy away from x equals 5. What is x? Is x a day of the month? Is it a age? You always want it to where someone else is reading your code, they know exactly what your variables are. Whatever style you choose to use, it's important that you do it and stick to it. You just want to have consistency throughout your code. Lastly, try to avoid using all caps for variable names. Alright guys, that's it for this video. I'll see you in the next. Alright guys, welcome back. In this lesson, we're going to be going over primitive data types and variables in C#. So let's get started. Let's go ahead and create a new project. We're going to bring up our console app. Next, we're going to call this data types. and we're going to create. All right, so we're going to go ahead and create our first variable. We're going to say int age equals 20. So what we're doing here is we're taking the value 20, we're assigning it to a variable named called age. Now you might notice a green underline under age. All that means is that the value is created and assigned, but it's never used. So let's go ahead and print that to the console. So we're going to write console.writeLine and age, no parentheses. And we want our console to stay up. So we're going to do console.read. And we're going to go ahead and give that a run. And as you can see, our variable age is printed on the console, and it has the correct value that we assigned to it, 20. And there will be times when you need to reassign the value of a variable, and that can easily be done by just calling the variable and giving it its new value. So we can say age equals 30, and let's run that. And as expected, you can see age equals 30, the new value has been assigned. So pretty simple there. So far, we've only been dealing with one data type. We've been dealing with the int. But there are quite a few more in C#. For an example, we can do strings. String hello equals hello world. And notice how the strings are written in quotes. And there are also bools, which represent variables that are true or false. So bool, say we were going to check something, check equals true. And we're going to get more into that as we move along. So let's go ahead and print that out and just see what those look like. So we're going to go console, WriteLine, hello, and we're going to do the same thing for our bool, which we call check. So that's the printout we expected. Our variable age 30, our string hello world, and our bool, which is true. Exit out of there. So I want to show you guys some other primitive data types. And as you can see, there's quite a few. We should be familiar with integer, as we were just using it for our age variable. An integer represents a value of -2 billion to roughly +2 billion. As you can see, they go down: U short, S short, S byte, and a byte. As you come down, there are variables for floats, doubles, characters, which represents a single character, bools, which we used for our check variable, and strings, which we wrote our hello world in. There's also primitive data types for dates and times, and we will be using that more and more as we get through the course. Now you might ask yourself, how do I know which primitive data type to use for my variable? And the answer is you want to use the smallest data type possible, but also being mindful of how large your variable can grow. As you can see, each primitive data type has a certain amount of memory allocated to it when it's declared. So a byte has 8 bits and an integer has 32. All right, I think that's a good stopping spot for us. I'm going to leave the link to this site in the description. I think a good thing for you guys to do is just kind of go through, learn about the different variable types, go back to Visual Studios, kind of play around with them, see what you get, and I'll see you in the next video. All right, guys, welcome back. So in this lesson, we're going to talk a little bit about the float and double primitive data types. So let's go ahead and get started. So in previous lessons, we've talked about the int data type. So for an example, you have int a equals 7. A lot of the other variable primitive data types are just a variation of the int. The short, the long, and the bytes are just ways of putting a whole number into a variable, but you pick the primitive data type based on the amount of space you want to allocate to that variable. But what if you don't have a whole number? Let's say you had int e equals 7.5. You see we get an error here. The compiler is warning us that if we did this, we're going to lose data. So how do we get variables that are decimals or not non-whole numbers? Well, we're going to have to use double, float, or decimal. So double b equals 7.5, and you see that works now. The other type, float c equals 1.5. Sorry. Another way of storing non-whole numbers. But you see we get an error here. That's because whenever you put a non-whole number, the compiler is going to assume that it's a double. And you need to put an F right behind a float to tell it that this is a float, not a double. Now you might be wondering, what's the difference between a float and a double? And the answer to that is the amount of space that's allocated to the primitive data type and the amount of precision. So for an example, a double is allocated 64 bits of memory, while float is allocated 32. So what does that mean? Float can support approximately 7 to 9 digits. So for an example, 1.5 9 digits, and a double can support 15 to 17 digits. And instead of just typing that out, I'll just write a note here, 15 to 17 digits, 6 to 9 digits. And with that, I want to show you guys an example of what can go wrong if you pick the wrong data type. So let's say we had another variable to int, and we're going to call it d, and it's going to be equal to 0. So there's no issue there. 0, integer, it's a whole number. But let's say we wanted to reassign the value. So let's say d now equals a plus b. So that's 7 plus 7.5, which should get us 14.5. But you see we're getting an error. Can't implicitly convert type double to int. So what it's telling you is that when we do this, we're going to lose data because the int can only store whole numbers. So it can only carry over the 14 and it would drop the decimal portion of it. Now, there's a way that we can force the compiler to recognize this, and I'll give you guys an example. So we can cast the results as an int, where 14.5 will now just be 14. and then we can cast it as a double. Sorry guys, I meant int. And let's print that out. As you can see, D was casted as an integer and it dropped off the 0.5 at the end. And the last thing is a primitive data type for non-whole numbers that I talked about in the beginning that we haven't covered yet, and that is the decimal. So we could say decimal E equals 7.5. And a decimal, just like a double and float, is for non-whole numbers. The only difference is there's even more precision as it allocates 128 bits of memory, and it supports 28 to 29 digits. And for decimals, you got to put an M at the end. So this is going to be really good for really precise numbers. So banking, when you're dealing with money, you're going to want to go with the decimal. All right, guys. So I think that's a good stopping place for this video. I'll see you in the next lesson. Hey guys, so today I want to talk about strings. And strings are just text or non-numerical values. So let me give you guys an example. Let's say I had a string and we wanted to call it name. And name's going to be equal to John. Let's print that out. And as you can see, our string that we put into our variable comes out as John. So pretty simple there. So C# also allows us to add strings together with something called concatenation. So let's take a look at that. Let's go back to our right line, console right line here. And let's say my name is, and we're going to use the plus sign to add this text to our string that's already defined. So let's see what that'll look like. And as you can see, it says my name is John, except is and John are one word. So let's fix that. What we're able to do in C# is add double quotes to signify space. So my name is space name. Now be sure you give a space in between the quotes, because that's how much space C# is going to give in between the two strings. So let's take a look. You see, my name is John, and everything's spaced out appropriately. All right, so let's look at another example. Let's change some things around. Let's say we changed this variable to first name. Let's create another string. Let's call this last name. Let's say Doe. And then another string. Let's call it full name. And what we're going to do is we're going to make full name equal to first name plus last name Oh, sorry guys. Now remember in our example below, we have to add the spaces or it's going to read this as one word. So let's do that. Quote space, quote plus, and we're going to change that variable here and call it full name. And now it displays the full name. My name is John Doe. So let's talk a little bit about the string class itself. So the string class is a part of the system naming space. And when you declared your string, you might have noticed that the namespace was no longer grayed out for system. So when you create a variable for string, you're creating an object of the string class. And that object has access to all the methods that are available through the string class. So let me show you guys an example. Let's take our first name. So first name, and as soon as you hit the dot, you get a lot of options that come up. So this first tab are the properties. So what you see here is length, and that tells you how many characters are in that variable. And the second tab over are your methods. These are ways that you can manipulate your string. So let's take a look at one. Let's say upper. So upper takes a string and makes all the characters in it uppercase. And what we can do is assign this to another string. So string upper equals first name to upper. So let's print that out. As you can see, it took our first name John and it capitalized all the letters. Let's take a look at one more. Let's do this with the last name. So last name, and there's one method that's called contains. It returns a bool of whether or not that variable contains a given text. So we can say contains Doe. And we can make a bool. Let's call this answer equals last name contains Doe. So it's simply asking, does this variable contain this text? Let's take a look. Oh, sorry, I forgot to add the printout. So let's do that. And as expected, our printout is true because the string Doe is contained in the variable last name. So next, why don't we do a challenge for you guys? Why don't you create a new variable and make it all uppercase and then use the lowercase method to basically make all the variables lowercase. All right, I hope you guys were able to do it. So let's just look at an example. So let's say string. Let's just call it text equals this, sorry, all uppercase. This is C#. Then we're going to create another string. We're going to call this lower. It's going to be equal to lower. And we're going to print that out. And as you can see, this is C#. And that's what we expected. All right, think that's a good stopping spot. See you guys in the next video. All right, guys, in this video, we're going to talk a little bit more about string methods. So let's get started. In our last video, we talked a little bit about strings, and when you create a string variable, you basically create a object of that class. So if you look below, when we create string uppercase equals test, uppercase is an object of the string class. And being an object of the string class, it has access to all the methods that come with that. So two of the ones that we used were the to lower and to upper, where we took an uppercase string and we made it lowercase, and we took an all lowercase string and made it uppercase. And there are many other types of methods, and we're going to just cover some of the most important ones. Let's start off with the replace and trim. The replace method replaces a character in a string. So if you look below, we have S1, which equals A. So what we do in the third line is we take the S1 variable and we use the replace method. And when you call the replace method, there are two things you need to pass. The first is the character that you're looking for, and then the second one is the character you want to replace it with. So here we're looking for the A and we're replacing with B. So A then becomes B. The second method, the trim, removes all the white space from the beginning and end of a string. So if you look at S2, we have a string with white space in front. So we call S2 and then we call the trim method. Let's see what happens. So as you see from the example, when we call the trim, it deletes all the white space from the beginning of the string. Let's go over a few more. The split method splits a string based on a specific value. The remove deletes all the characters from the beginning to a specific index position. The compare to compares two strings and returns an integer, 0 for false, 1 for true. Ends with checks whether or not a specific character is the last character in a string. Equals, it returns a bool of true or false if a string is equal to another. All right, I just wanted to cover some of the more common string methods. You might see us use some of these as we move along in the course, but mainly I just wanted to give you guys an idea of what's possible with C#. I'll see you guys in the next video. All right, everyone, welcome back. So in this video, we're going to talk about casting, and let's get started. So casting is when you want to change the data type of a specific data from one type to another. So looking at our example below, you can see we have an integer that we declared called number, and it's equal to 42. And what we do is we create a float called number2, and we assign it the the value of number. So float number2 equals number. So there are two types of conversion. There's implicit and there's explicit conversions. Implicit conversions are the type of conversions that require no special syntax to convert the data. In these type of conversions, there's also no risk of data loss. So if you look at our example below, we have an integer that we named A, and it's equal to 7,897. We also declared a long B, and we made it equal to A. This works because the integer 7,897 fits comfortably into the range of a long. So there's absolutely no risk of data loss. On the other hand, explicit conversions require a casting expression to ensure that there is no data loss. As you guys can see by the image below, we have a float A that equals 1968.7, and we try to cast it into an integer B, but we get an error. This is because integer only supports whole numbers. So the compiler is telling us that everything after the decimal would be lost. If for some reason we didn't care about the data being lost, or we wanted to show this variable as an integer, we would use a casting expression. So as you see On the first line, we still have our same variable, the float. And on our second line, the integer b uses a casting expression to cast a as an integer. So instead of 1968.77, we only get the whole number part of it, 1968. So as I stated before, explicit casting is used when you know the data type will be a certain type later, or you don't care if the data is lost. So let's talk about the convert method. You can see we have a byte called number, and it equals 45. And on the next line, we cast that into an integer as int cast. And we've seen this before. This is an implicit conversion, as a byte fits comfortably into an int. On the third line, we have another integer as int convert, and we use the convert to method to basically do the same thing. We take the number, we put it into the method, and it converts the byte into an integer, and we get the same results. Now, there's some important differences between the casting and the convert methods. When you use the casting method, especially with explicit casting, you're basically saying, I understand that there's going to be data loss, or there may be data loss, but I want to display this variable as this type. So let's look at an example. We have a double called real, and it equals 1.6, and we cast it into an integer in the next line. And when we cast that double into an integer, we're left with 1. Now, we do the same thing on the third line, but we use the convert to method. And notice the difference. We get 2. So instead of getting rid of or truncating everything after the decimal, the convert to method actually rounds the number up. So that's really something that you have to be mindful of when you're programming, the difference between those two ways of converting data types. Now let's talk about converting strings into integers. As you can see in this example here, we have two strings, number and number 2, and they equal 42 and 10 respectively. So when we try to add those results together, or those variables together into the variable results, we get 4210. Because these are strings, that's concatenation. We basically take the two strings and we put them together. But what if we needed real numbers, where we needed to perform some type of math operation or something like that? So what we want to do, if you come down to the fourth line, we use the convert to method to take number and number 2, and we convert those into integers. Number as int, and then number 2 as int. So then on the last line, as you see, we have results 2. Number plus number 2 now equals 52. Let's look at an example of doing the opposite. Now the same variables, but now they're integers, 42 and 10. On the next two lines, we take those two integers and we use the convert to string method to convert those two integers into strings. And then we add those two together to create the results, and the two strings concatenate into 4210. Now for a challenge. I want you guys to declare a string with the value of 5 and a float with the value of 235.96. Lastly, declare an integer that equals the sum of the first two variables. So 5 must be a string, 235.96 must be a float, and the results variable must be an integer. And of course, your program can have no errors. So go ahead and pause the video, give that a try, and I'll have the solution in the next video. Alright guys, welcome back. So before we get into the solution, I do want to say this. When we do the challenges and the solutions, a lot of times your solution may look a little different than my solution. And in programming, that's okay. There's different ways to approach the same problem. So if your solution doesn't look the same as what you see on my screen, it's a-okay as long as you got the correct results. So with that said, let's go ahead and get started. The first thing we need to do is create a string that's equal to 5. Next, we need to create a float. equal to 235.96. So as we learned in the previous video, we can't add these two numbers together. So let's take a look. So let's say we had results, which is an integer, equals string value plus float value. And as you can see, we get an error. We can't add a float to a string and then try to put it into an integer. So we need to convert these variables before we can actually use them in results. So let's do that. Let's start up top where our string value is. So this needs to be an integer. And we're going to call this string value as int. And we're going to make this equal to convert to int32. And what we're going to put here is the value that we're converting, which is string value. So string value. So we're taking the value, string value, which equals 5, and we're converting it into an integer, and we're storing it into an integer that we named string value as int. So fairly simple there. And we're going to do the same thing with the float. So we're going to create an int, and we're going to call this float value as int. And we're going to make this equal to convert to 32, and then we're going to put the value that we're converting, which is float value. So same thing, we took the float and we passed it to a variable, a float variable called float value as int here. And as you guys may know, you could have also used a casting expression to achieve the same results here. So let's just take a quick look at that. Let's get another variable here. It's called int float. Well, actually, let's just use the same name here and just call it 2. And we could have made this equal to float value. And we could have just cast it as an int. And that would have given us 235. So it's the same thing we did above here. So there's two ways to do that. And you would have to change the name here. So there's two ways you could do that, but we only need one of these values, the variables. But there's one thing to remember. As we spoke about in the previous video, the convert to method rounds up to the nearest whole number, and the casting expression truncates everything after the decimal. So depending on the result you're trying to get, you would decide which one you'd want to do. But I didn't really specify that in the instructions, so you're not wrong either way. Alright guys, let's take a look at our last line, the results integer. So originally we had the string and the float that we tried to add together, and that didn't work. Only thing we need to do now is switch those two variables out with the converted variables. So string value needs to be string as int, and float value as int. Let's print that out. And as you guys can see, we get our expected results, 241. All right, I hope you were able to come up with the solution on your own. If not, I hope this was helpful. If you're still a little confused, please go back and look at the previous video that covered this topic, and I'll see you guys in the next video. All right, welcome back. So in this video, we're going to talk about the console class. The console class represents the standard input and output and error streams for console applications. So we've seen this before. You can see the example below where we would write console.write and console.writeLine to print something to the console. And what we've also worked with is the reading streams, the read line, the read, and we haven't seen the read key yet, but these are all ways to read user input. So previously we've been using the read and read line to just keep the console up, to allow us to display what we're writing to the console without the application closing. But now we want to focus on using these methods to get some type of information from the user and then doing something with that information. Now, anytime you call one of these methods, the read key, or read line, this is what comes up, the blank console. And in previous videos, we would write something to the console with the console.write or the console.write line. But this is just going to be your standard console with nothing on it. And it's just waiting for the user to enter in some type of information. So let's talk about the read key method. So the read key returns one single character from the standard input stream or command line. So we've seen this before. When you're in an application, it says press Y to continue or select one, A, B, C. That's an example of that. So whenever you call the console.read key, it returns a value that's of the type console key info. Console key info is just another primitive data type as an int would be or string. So what we're doing here is we're declaring a variable info and we're assigning the value of it to the console.read key. So when console.read key is called, the console will show up and the user will enter in something. And whatever that user enters, that character will then be transferred into info. So if you look at the line below, we have a char A, and if you guys remember, the char represents a single character. And then what we're doing is we're taking that variable we created, info, and we're accessing the character that it was a part of the console key info. So we're going to access that character by going info dot key char. Or to make that simpler, guys, all we're doing is getting the key that the user has entered and putting that into the info variable. And one of the properties, or I'm sorry, the methods that the console key info has is a key char method that gives you the character of whatever that variable equals. So we've seen this before where we did the string class, and the string class has certain methods that allows you to manipulate that variable or change that variable or do things to that variable. So what key char does is it takes whatever character that was entered and it turns it into the data type char. Now let's talk about the read line method. So the read line method reads a single line from the standard input stream. And what's important here is that whatever is entered is returned as a string primitive data type. So that includes numbers as well. And later on, we'll get into the parse method and how to deal with numbers, but that's important to know. So let's look at an example. So we have a string that we call A, and we call it the console read line. So what this is going to do is just pull up the console, and whatever we typed, if we typed hello world, that string will now be applied to the variable A. So A would equal hello world. And the last method is the read method. And what's important here is that it returns an integer. And if nothing is entered, it returns the value -1. But if anything is entered, it returns the decimal equivalent based on the ASCII table. So let's just look at an example here. Let's say we have an integer, we call it number, and number equals console.read. And let's say the user, once the console came up, the user puts in the letter capital A. And what would happen is it would return the decimal value based on the ASCII table, and that would be assigned to number. And when we print number, we would get 65. And if we look at the table, we can see here, highlighted, capital A equals 65. And you guys can Google this table just to kind of get familiar with it, to understand it. I didn't think it was too important to include in this course. It would be something that you would kind of look up if you need it. And lastly, let's talk about the methods that are used to write to the console. We've seen these a lot, the write and write line, where the write line prints one or more objects to a single line, and the write does the same thing. The only difference is that the write line has an escape character on the end that creates a new line, and the write method does not have that. So if you look at the following example, see we use the console.write to say hello and then world. And then we used console.writeLine, but we didn't write anything in it. And what this is going to do is going to create a space in between the last write and the write line that's run right underneath the blank one. So hello is going to have a space from world that's above. And then we write another console write line world. And then of course the console.read to keep the console open. Let's see what that's going to look like. As you can see, the hello world is all on one line because we use the console.write. And then below is hello. And if we didn't put in that blank console write line, what would have happened is the hello that's on the second line would have been right after world. So it would have said hello world, hello. And then down the last line, because we use console.write line, world is on its another line as well for the third line. Alright guys, I think that's a good stopping place for this video. I'll see you in the next video. Alright, welcome back. So in this video, I want to talk a little bit about the parse method. So in the past, we've seen the convert to int method, where we took a string and we converted it to an int. So for an example, we had a string that we called age, and age equals 30. And we came down and made an int and call that age int. We can use the convert to method and pass age, and now that's an integer. Now let's go back to the first line here. Let's say instead of assigning 30 to age, we would ask the user what the age is. So we say console.read line. Now the console will appear, and let's say we're going to write here console.writeLine, and we're going to write a string, my age is, and then we're going to add age, and we want to keep our console up, so we're going to do console read. Now let's take a look. All right, so we're going to go ahead and enter our age. Let's say 30. And you see we get our expected results. My age is 30. So as you can see, the convert to works perfectly for that. But one thing about convert to, if the value is null, it won't throw an error. And sometimes in your program, you want to know if a value is null or not before you try to do some kind of operation on it and break your application. So for that, we're going to use the parse statement when dealing with user input. So let's just rewrite this here. We're going to say int age int equals 32.parse. We're going to pass age. So same thing there. And let's just go ahead and just write up here console.writeLine, how old are you? So let's run that again. All right, so we have our prompt, how old are you? And we enter the age. And there it is, my age is 32. And we could add a space there just to kind of make that look a little cleaner. So remember, you add the two quotes, add a space in between two concatenated strings. All right, so there's one thing to consider. So we ask the user for their age and they punch in the number, and we take the number and we parse it. But what if they don't enter in a number? What happens? So let's take a look. All right, so let's say the user gets this prompt, and instead of putting in a number like we expect them to, they put in a letter. So let's just say K. And let's hit enter. See, we get an error. Input string was not in the correct format. That's because you can't parse a letter into a number. So when a user puts this in, it crashes your program. So what can we do to avoid this? So let's stop the program. This is where the try parse method comes in. So this is what we're going to do. We're going to comment this out. And we're just going to use the same variable name, but we're just going to declare the variable age int. We're not going to define it yet. All right, so now we're going to say int 32 dot try parse. And so it's a little bit different than the parse method. You're going to put in your string value, age, right above here, because we're collecting the age, comma, out. And then you're going to put, if this is successfully parsed, what variable is the value going into? And that's going to be age int. So out age int. So what we're doing is we're trying to parse age, and if it works, we're taking that value and we're putting it into age int. Pretty simple there. So let's go ahead and run this and see what we get. Let's go ahead and put in the same thing. So the user says K instead of being a number. So we get age is 0. And most importantly, it doesn't crash our program. And it's age 0 because whenever you declare an int without assigning a value, by default, it's 0. Now, as we get along in the course, you'll start to learn more about loops and if statements and just controlling the flow of a program, where if for some reason they put this in and age equals 0, we can keep asking them to enter age that is above 0. Now for a challenge. Why don't you guys create an application that asks the user for their name and then asks them for their age and then prints it out? All right, I hope you guys were able to do that. So let's take a look. So first thing I want to do is just comment out all of the code here. We're not going to need it. You can do this really quickly just by going here to the right hand corner and clicking the comment out selected lines. So we did that. So let's go down here and create our variables. So we need a string name. We need a string age. And we need an int. Let's call this age int. So first thing we need to do, we're going to ask the user for their name. So let's console.write line. What is your name? And we need to capture that information. So we're going to say name equals console.read line. So whatever the user puts in is going to be equal name. And I'm not sure if we've seen this before, guys, where you could declare your variables ahead of time and just define them later. Because you see I declared string name, and whenever I want to declare it or add a value to it, I just go ahead and just write name without the string portion, and I assign it whatever it's equal to. So let's come down, and we're going to do the same thing for age. We're going to console.write, and we're going to say, how old are you? Now remember, the console.write returns a string, so our string age is going to be equal to console.read. So pretty straightforward. We ask what the name is, we get the value, and we assign it to name, and we do the same thing for age. Now that we have the age as a string, we just need to parse it. So we're gonna use the try parse method. So we're gonna try parse, int try parse. We're gonna put in our string, which is age, and comma out, and we're gonna send it out as age int. Now, only thing left to do is print that out. So let's do that. Console.write line, and we're gonna say my name is, and we're gonna put name, and we're gonna do another line, console. We're gonna say my age is, age as int. And we want to keep the console up, so console.read. So pretty simple there, guys. Now, remember what I said in previous challenges. Your code might not look like this, and that's okay. There's more than one way to solve this problem. Let's take a look. All right, so here's our prompt. What is your name? And I'm going to enter my name, Eric. And it says, how old are you? And I'm going to enter my age. And we get our results. My name is Eric. My age is 33. All right, guys, I hope you were able to do that. I think this is a good stopping point, and I'll see you guys in the next video. All right, guys, welcome back. So in this video, we're going to talk about operators. So operators are just symbols that tell the compiler to perform a math or logical operation. So let's take a look at some of these. Let's start with arithmetic operators. The first one here, A plus B. Well, before we get into that, as you can see above, we declared two variables, A and B. A equals 10 and B equals 7. So the first operator is the addition operator. So adding the plus sign in between two variables, you're able to add them together. We've seen this a lot too when we were concatenating strings. So this is the addition or concatenation symbol. Next is the subtraction, A minus B, which would equal 3. Next is the division, A divided by B, so 10 divided by 7. Next is the modulus operator, which is represented by a percent symbol, so A percent B. And what this does is it divides the numbers, so A divided by B, and it returns the remainder. So 10 divided by 7 would give you a remainder of 3. So that would be the result of A modulus B. Next is the increment symbol, represented by two plus signs. So as you can see, we have A, which equals 10, and we add the increment symbol. And what it's going to do is add 1 to whatever the value of A is. But there's something to remember here. There's an important fact to remember when dealing with this. The increment symbols can be added before or after the variable. So if you look at our first example, A, then followed by the increment symbol, it still equals 10. That's because the increment didn't happen until after the variable was called. But in our next one, we put it before, now it equals 11. And you might be wondering, why would I ever put it after if it didn't change? And this is something we're going to look more into, and it's going to make a lot more sense once we get into loops, why you would ever put the increment after and not before, or just understanding the different situations where you would want to use one or the other. The next two are the decrement operators, which do the exact opposite of the operators discussed above. They decrement the variable by 1. Next, let's talk about the rational operators. The rational operators return bools, which, if you guys remember, are primitive data types that are true or false. So let's start with the first one. You can see we have A double equal signs B, and this is different from the single equal sign. With the single equal sign, you're assigning a value to a variable. So if I said A equals B, then A now would equal 7 because B equals 7. But with the double equals, it's asking a question, as all of these rational operators are. You should think of them as questions. It's saying, is A equal to B? Is what's on the left equal to what's on the right? And that would return false. Next, we see A, an exclamation mark, and equals B. And anytime you see that exclamation symbol, it means not. So it's asking, is A not equal to B? And that's true. A is not equal to B. Next is the greater than, and below that is the less than symbol. Is A greater than B? Is A less than B? And then as you can see below that, the last two are the greater than or equal to, and the less than or equal to. Is A greater than or equal to B? Or is A less than or equal to B? And to kind of check your understanding, you guys can pause the video right quick before I kind of give the answers to what those would be. All right, hope you guys were able to figure that out. So the first one is A greater than B. That would be true, which would make the one below that false. A is not less than B. Is A greater than or equal to B? That's true. And is A less than or equal to B? False. Let's move on to the logical operators. So for the logical operators, we have the and symbol, the or symbol, and you can achieve this, the or symbol, the two lines here, by hitting the backslash while holding the shift button. So just hold shift, hit backslash twice. And then the not symbol, which we saw this before in the not equal, but I'm going to show you a different way of how to use that. Now, these symbols are going to come into use when we get into our sections about controlling the flow of a program, if statements, and the loops. But just as a preview, the way one of these statements would work, as you see below, I have an if statement. And don't worry about it. We're gonna have a whole section on if statements. But just for the sake of example, an if statement basically says, if something is true, then perform this line of code. So as you can see, that's what we have here. So we have if A equals B and B is greater than 20, then perform this line of code. So relatively simple. The and symbol checks both, and if they're true, it performs the code. The or statement checks both, but only one has to be true. Below that is how to use the not symbol. It basically reverses the logic of whatever you're dealing with. So is A less than B? The answer is false. But when you add the not operator, that reverses the logic. So now it becomes true. And we can just go ahead and run this, see what we get. All right, so as you can see, our results from our math operators. Then make note here of when we use the modulus operator, where it prints the remainder. So 10 divided by 7 has a remainder of 3. And then below that are the increments, and then the answers to the logical operators. All right, guys. So I think that's a good stopping place. See you in the next video. All right, guys. So in this video, we're going to talk about methods. And methods are just a group of statements that perform a task. So every program has a method. If you recall, every time we've opened a new application or you start a new file, you'll have a static void main method. This is the main method that every C# program has, that as soon as you run an application, the compiler looks for this main method and starts to run the code within it. What we're going to learn to do is create our own methods. This will allow us to save time by being able to call these methods to perform specific tasks, and it'll make our code a lot cleaner. So let's look at some of the elements that make up a method definition. So one of the first things is the access modifier, the return type, the name of the method, and a parameter list. That's how you define a method. And we're going to go over each one of these and give examples. But once your method's been defined, you then write the body, the code that needs to be executed every time you call this method. So let's take a look at a few of these elements. The access modifier determines the visibility of a variable or method from another class. We're going to talk about that more as we get into the classes and object-oriented programming. But for now, all of our methods are going to be public. Next is the return type. Some of the methods you create will have to return values. And the return type is where you specify what type of information it is. Is it a string? Is it an int? Is it a double? So that's what a return type is. The method name. The method name is going to be your unique identifier. It's going to be case sensitive. And anytime you want to call on this method to perform a task, you're going to have to call it by that name. The parameter list. The parameter list is used to pass and receive information from a method. And I think this is one of the things that are better seen than explained. So we're going to have examples coming up. And the method body is going to be the instructions or the code needed to perform a task. So let's look at our first example, void methods. So as you can see, we have our main method. But below that, after the brackets, we declare our own method, public. And we have to use the static keyword because our main method is static. So public is our access modifier. And then our return type is void. We're not returning anything from this method. So we're going to say void. And we're going to give it a name. The name of our method is going to be say hi. And now that we've defined our method, the last thing we need to do is give the method the instructions that we want it to carry out every time we call it. So in this case, we're writing to the console hi from a method. Now to make a method work, only thing you have to do now is call it from the main method. So if you look above, we call say hi from the main method. So when the program executes, it sees the method call and it will print hi from a method to the console. So now let's look at methods that have return types. So let's first look at the method that we declared, say hi. And you can see now, instead of void, we have string. That's because we're going to return a string. And we've also made some changes to the body. We declared a string called hello. And hello equals hi from a method. Then we use the return keyword to return that variable. Now let's look at our main. In our main, we have a string called hello main. And hello main equals say hi. So when say hi is called, it declares a string, hello, defines it, hi from a method, then returns that defined variable to the main. So string hello main equals whatever is returned from the say hi method call, which is hi from a method. And in the next line, we use the console.write to print hello main to the console. Now let's look at methods that take on parameters. Let's look at the method we declared, add4. So it's a public static int, so it returns an int, and the name is add4. And it has a parameter. In the parameters, we define what type of variable it's going to take on. So we want to pass an int to this method. And for the parameter name, it can literally be anything. I mean, anything within reason that makes sense to what you're trying to do. So now let's look at the first line of the method. We declare int, and we call it value. And value is going to be equal to my number plus 4. My number is what you call the parameter in your parameter list. So when we get a parameter, we're going to call it my number, and we're going to add 4 to it. And we're going to assign it to the variable value. And we're going to take value and we're going to return it back to the main. So now let's look at the main. In the main, we declared int number 4. And in the next line, we declare an int new number. And new number is going to be equal to the method add4. Because we define this method with a parameter, you have to pass a parameter whenever you call the method, or you're going to get an error. Now notice that the variable that we pass doesn't have to match the variable that we gave in the parameter list. The parameter list has a my number, and the variable that we pass is just number. Whenever you pass anything to a method, whatever you pass then becomes referenced as whatever is in that parameter list. So the value of number is now going to be my number. So if my number equals 4, when we pass it to the add 4 method, it takes the number 4, it adds 4 more to it, and gives that number to value, which is 8. And then value is returned to the main method and assigned to new number. So new number equals whatever is returned from add 4 with the parameter number. And in the next line, we just print those results. All right, so we're going to wrap that up. And the next few lessons, we're going to give some more examples of methods and just get a little more practice. That way we can really understand what a method is and why it's useful. All right, guys, welcome back. So in this video, we're going to talk about if statements. And if statements is a block of code that only runs under a certain condition. So let's look at an example. Let's say we had two numbers, right? So let's say int number 1, let's make it equal 5. Then we had int number 2. Let's say it equals 10. Now let's create a condition based on these numbers. Let's say if number 1 is greater than 3, I want to print number is greater than 3. So fairly simple. If the value stored in this variable is greater than 3, then execute this block of code. Then we can come down here and we can also say number 2 equal to 10. We're going to write this is true. Print that out and take a look. So we're just going to do our console.read line. As you can see, both of our lines of code print because they're all true. So let's add something that's false in there just to show how the code won't execute if the block is false. So let's say keep the variable number 2 and let's say if it's less than 3. Or we can compare it to number 1 if it's less than number 1. Print that. And as you can see, we get the same 2 lines that are true, but our third line did not print because it doesn't evaluate as true. This is because number 2 equals 10, and it's not less than number 1, which equals 5. Now, what's important to remember, anything that's written outside of the if statement will execute automatically. So as I'm running through my program, the compiler would check all of my if statements, whether they evaluated true or not, it'll go to the code that's underneath and run it. So for an example, this runs no matter. So pretty simple there. So next, we're going to create a small application that utilizes this concept. So what we're going to do is comment out all the code here. And let's say we made a application that told a student whether or not their grade was passing or failing. So first thing we're going to need is a grade. So we're going to call it int. We're going to give grade a value of 80. And next, we're going to create a function. We're going to call it pass or fail. And it's going to accept an int. And we're going to create an if statement. We're going to say if grade greater than 70. We're going to say pass or student pass. And we're going to put another if statement. If grade is less than 70, I'm going to say student did not pass. And within that same function, I'm just going to write our console. Actually, we're going to do it up top here because we still have to call the function. So we're going to say pass or fail. This method needs to be a static method. So let's run it. And because the grade is above 70, the student passed. And if we were to make another int grade 2, let's say they didn't do too well on their second grade. and they got a 50. And we called as grade 2. Running that again, we have student passed, student did not pass. All right. In the next lesson, we're going to cover the if else and else statement, because there's certain times where when you have multiple if statements, multiple things can be true, and you don't necessarily want those if statements to execute. You want to do them in a sequence. If this is true, then don't do this. Or if this is false, then do this. If that's also false, then do this. So we'll cover that in the next video, and I'll see you there. All right. In this video, we're going to talk about the else if and the else statement. So let's get started. Let's start off with an int, and we're going to call it grade. And grade's going to be equal to 76. Let's write an if statement. If grade greater than 75, we're going to print a message that says you pass. All right, just like we saw in our last video. And in this case, grade equals 76. So when it encounters this if statement, the code in between the brackets would be executed. Now, what happens if we want another condition where if it's not greater than 75, we want it to do something else? Now, the first reaction would probably be to just write another if statement. And that could work. But in certain situations, that second if statement could also evaluate as true. So for an example, if I had an if statement that said, I'll just copy this over and said, instead of greater than 75, let's say equal to 76. And I had a message that would print whenever it equals 76. The problem is that with this is that both statements would evaluate as true and the code would be ran for both. To avoid this, we use the else if and else statement to run things in a sequence. So let's go ahead and take a look at an example. We're going to modify our second if statement, and we're going to change that into a else if. So just else if, and we're going to say else if grade equals 75. We're going to print a message, and we're going to say study more. So to review that, if the grade is greater than 75, then we get the message you passed. Else, if the grade is equal to 75, we're going to get the message study more. Lastly, we're going to talk about the else statement. And the else statement is a block of code that executes only if the if and the else if statements above it evaluate as false. And you don't necessarily have to have the if or the else if. You could have an if and an else statement. Just want to clear that up. But let's go ahead and take a look at that. So we're going to say else, and we're just going to put our brackets. And the code that we want to run is we're going to just write you didn't pass. So there it is. We have our if, else if, and our else statement. If the grade is greater than 75, we're going to print you pass. If it's equal to 75, we're going to say study more because you almost failed. And if it's below, or I'm sorry, if none of those evaluate as true, we're just going to go ahead and print what's in the else block, which is by process of elimination, you didn't pass. Next, I want to show you guys an embedded if statement. So first thing we're going to do, we're going to comment this out. We don't need this. We're going to keep the int grade variable and comment out the rest. And then we're going to have a string. We're going to call it message. We're not going to assign it yet. We'll do that in the code. Create a little space. And what we're going to say is if grade is greater than 75, and we're going to have our block here. And what do we want to do if grade is greater than 75? We want to find out exactly what the number is and assign it a letter grade. So if grade is greater than 75, we're going to create another if statement within this if statement and say if grade greater than 93. And what we're going to do is we're going to take the variable message, and it's going to be equal to the letter grade A. And actually, instead of making this a string, we could have easily just have made this a char. Then we're going to say else if the grade is greater than 85. And we're going to use the and. So we're going to say and grade is less than 93. We're going to run the block of code here. And the reason we're getting this, we need to do single quotes. So else if the grade is greater than 85 and the grade is less than 93, meaning it falls in between the number 85 and 93, the message will be B. And we're going to do another else if. So then we're going to say else if grade is greater than 77 and the grade is less than 85, we're going to say message equals C. Lastly, we're going to come in with a else. And in the else statement, we're going to say, actually, we're just going to do a console.write. And we're going to say grade was less than a C. Now let's recap before we move on. So we have our int grade, which equals 76. And then we have a char message that we have not defined. And what we do is we have an if statement that if the grade is greater than 75, it's going to enter this block of code of these embedded if statements, because these if statements are embedded into this parent if statement. So the grade is greater than 75, then it comes down. If the grade is greater than 93, the message will be an A. If it's between 85 and 93, it's going to be a B. And then 77 to 85, it's going to be a C. And else, if it meets none of those criteria, we're going to say grade was less than a C. Next, I want to address what we need to happen if the grade is under 75 or 75 or less. So we're going to do that with a else statement, which is outside of this parent. So we're going to say, we're going to come down underneath everything that we wrote here. So the if statement starts here and it ends here. So our else statement goes here. And we're just going to put you didn't pass. Lastly, we're going to come down and say message equals F. So one last recap, just to make sure you really got that. So if the grade is greater than 75, then we're going to enter these embedded if statements and go through them each. And whichever ones evaluate as true, you would assign message that grade or that character. But if the grade is not greater than 75, it skips that and comes down to the else statement, where it just writes, you didn't pass, and it assigns the message F. If we wanted to, we could have came in here, every block of code, we could have did a console.write line and wrote the message and said grade equals A, grade equals B. But I think you guys get the idea. Now, after this lesson, you might be thinking this is a really complicated way of doing things. And you're correct. In the next lesson, I'm going to show you guys the switch statement, and I'll show you how to handle this a lot cleaner. So this is going to be a good stopping place for us, and I'll see you guys in the next video.